Hello everyone, welcome to Headway Civil Online Study. Today we will look at the properties of soil. Under this chapter, the first thing we will study is the soil phase relationship. So soil mass is generally a three-phase system consisting of solid particles, liquid and gas. Here liquid we mean to say is water and by gas we mean to say is air. The phase system is expressed either in terms of mass volume or weight volume relationships. So if we say this somehow like this, either in terms of mass volume or weight volume relationship. And this is important that soil phase is a three-phase system. So if you draw the three-phase system, it looks somehow like this. It's comprising of three phases, and the first phase is solids, so we write over here solids. Second phase is liquid, that is water, and the third phase is gas, which is air. We can represent these three phases in terms of mass volume, weight volume. That means one side let us write in terms of volume and the other side we write it in terms of weight or mass. I'm writing here in terms of weight. So weight of air, weight of water and weight of solids. Here I am representing it in terms of volume. So this is my volume of air, volume of water and volume of solids. We know air has got no weight. So what happens? The total weight will be the summation of weight of water and weight of solids. Since weight of air is 0, so the total weight of the soil mass is actually the summation of these two. So this is the total W. Here the total volume, let us represent it in terms of capital V. So the total volume will be summation of volume of air, volume of water and volume of solids. Right? Now remember one thing, if we consider, if we draw it somehow like this, that solid particles are there and in this portion what is there is actually these are the voids that is present within the solid particles. This is entire is a soil mass which is comprising of these solids and these are the voids that is present. And the voids may consist of either air or water. So it is the voids which comprises of air or water. So the volume of air and the volume of water together comprises of the volume of voids. So we can write volume of voids is actually volume of air plus volume of water. In certain there are special cases where we can say the volume of air is 0. That means the volume of voids will be just equal to the volume of water. Or we might say the volume of water as 0. In that case, we will consider the volume of voids equals to the volume of air. So let us look at these two conditions. The first case, let us consider the portion when we are considering the volume of water as equals to 0. From this equation which we have, the volume of voids equals to volume of air plus volume of water. When we consider the volume of water as 0, then volume of voids is becoming equals to volume of air. If that means we are considering these solid particles and within the voids there is only air present within these voids. There is no water present, right? That means in such condition we can consider the soil as a dry soil. And if someone asks me to represent it in terms of phase diagram, how it will be, there will be no air, water, there will be only air and solids present. So there will be only air and solids. So this is actually the volume of air and volume of solids which will comprise of the total volume. Fine. And the second case we can consider is when we are considering the volume of air as 0. So if you consider the volume of air as 0, that means This is the soil solid particles, and we are considering the void is filled completely with water. There is no air present. That means the volume of voids becomes equals to the volume of water. In this condition, we consider the soil as fully saturated soil. This can also be represented in terms of phase diagram. So this is also will be converted, the three-phase diagram of the soil mass will be converted into a two-phase diagram comprising of water and solids. So here will be just the volume of water and volume of solids, which will comprise of the total volume. Fine, these are the two cases, and questions comes like this. If the volume of air becomes zero, then the three-phase system will get converted into, say the options will be one-phase system, two-phase system, three-phase system. So the answer will be a two-phase system where it is comprising of only water and solids, and if the volume of water becomes zero, it will become a two-phase system comprising of air and solids. Right? So these are the two conditions. Next, let us move on to the portion. Uh, Let us understand few of the terms. Terms like unit weight and density. Density we represented it in terms of rho, and unit weight we represent it in terms of gamma. Okay, unit weight can be referred to as weight by volume, and density can be referred to as mass by volume. Okay, so in terms of, there will be a relationship that will there will be a relationship between unit weight and density. How we can write it down? Since gamma is equals to weight by volume, and we know W is equals to mass into G, where G is the acceleration due to gravity, which is considered as 9.81 meter per second square, right? So we can write it as equals to mass into G by volume, and M by V, we know it's equals to rho, so therefore we can write it as rho g. So remember, gamma is equals to rho into g. This equation is required because questions generally comes, and in while doing sums also you'll find this problem. If density is given, to convert it to unit weight, then you just multiply it with acceleration due to gravity, which is 9.81 meter per second square. Okay, just remember this, the density of water is actually 1000 kg per meter cube, or we can write it as 1 gram per cc. Okay, so if anyone asks to convert this density into unit weight, what we will do is gamma of water will come out to be equals to this rho, which is 1000 into, since we know it's equals to rho into g, so we can multiply it with g, which is 9.81, right? So this is actually, the unit is meter per second square, and here the unit is of 1000 kg per meter cube. So if we do this, multiply this one, it will come out to be this kg meter per meter cube into second square. Again, kg meter per second square. This portion we know is as Newton. So this comes out to be 9810 Newton cube, or we can write it down as 9.81 kilonewton per meter cube. Okay, just remember this thing, that gamma of water is equals to 9.81 kilonewton per meter cube. Certain times for problems, generally we take as, for problem solving, we take gamma of water as 10 kilonewton per meter cube. This is for our convenience, we take it. Okay. Next, let us move on to some of the volumetric ratios we have. So there are basically, in general condition, we have got three volumetric ratios, but there are also another one which will be included, that will study is the air void ratio. Let us look at the first volumetric ratio we have. Volumetric ratios means what? That is, the numerator is also volumetric representation and the denominator will also have a volumetric representation. So in void ratio, it has been told that it's the ratio between the volume of voids and the volume of solids. So in the previous phase diagram, if you look at, is volume of voids is actually volume of air and water together forms this volume of voids. And when we divide this with the volume of solids, we get what is known as void ratio. So we can say void ratio is actually equals to volume of air plus volume of water by volume of solids. Now the question might come, can void ratio be equals to 0? This will be somehow the question. Can E be equals to 0? See, if we consider these solid particles, how tightly might be this orientation might be. Some of the voids will definitely be present within these particles, even if the packing is too close, too compact, then also there will be few voids which will still persist within these particles. So we cannot make volume of voids totally equals to 0. This is not possible. So volume of voids can never be equals to 0. Since volume of voids can never be equals to 0, so we can write E can never be equals to 0. So here it is written, void ratio of a soil mass can never be 0, can never be 0. It's never be 0. It can have any values greater than 0. So E has to be somehow like this. This is the condition that will be followed. Okay, and remember E is always represented in decimal. Fine. Next, move on to the porosity. Porosity is actually the ratio between the volume of voids and the total volume. In void ratio, we saw that it is the ratio between the volume of voids by volume of solids. Here, the denominator was solids with respect to solid, and here the denominator is the total volume. Fine. Next, the same question. Can n be equals to 0? Can n be equals to 0? Is it possible? Again, volume of voids can never be 0. So we can write n can never be equals to 0. This is the first condition, right? Can n be equals to 1? Or we can say can n be equals to 100% since it's represented always in percentage porosity. Can n be equals to 100%? Is it possible? Okay, let us find out. For this, what we need to, n equals to volume of voids by total volume. To make it as 1, what we need is volume of voids equals to volume. But is it possible? Can, since it's a three-phase system, soil mass, air, water, solids. This is my volume of voids and the total volume. If the volume of voids becomes equals to the total volume, that means what? Volume of solid is becoming 0, and it can never happen that in a soil mass solids are absent. So we can say n can never be equals to 100%. So n values always exist somehow like this. It will have value greater than 0 and less than 100%. Fine. Let us move on to the degree of saturation. So degree of saturation is the ratio between the volume of water and volume of voids. The volume of water, that means the same question will persist here also. Can A's be equals to 0? Can A's be equals to 1? And what is basically the value of A's which will persist? Okay, so volume of water can be equals to 0, which I already told you in my last discussion that if the volume of water becomes equals to 0, then it becomes a dry soil, right? So this is possible. So if the volume of water becomes equals to 0, then we can say the soil is dry soil. Again, can the volume of water be equals to volume of voids? That means what? Volume of voids equals to volume of air and volume of water. If I'm making the volume of voids equals to volume, that means I'm making the volume of air equals to 0. That means this is standing out for fully saturated soil. Right, so this condition is also possible. So the value of 0 lies somehow between this. it can be 0, and also it can be 100, and it can have any values between this. If it's 0, then we consider the soil. If dry soil, Ace will be 0. For fully saturated soil, Ace will be 100. Okay, so when Ace is 0, we consider the soil as completely dry, and when Ace is 100%, we consider the soil as fully saturated. So both of these conditions persist. Next, let us move on to the year void ratio. Year void ratio is the ratio between the volume of air and the total volume. Okay, this is also represented in percentage. So how this equation is coming, let us see. Volume of air, since volume of voids equals to volume of air plus volume of water, we can write volume of air as volume of voids minus volume of water. So air void ratio, which is given as volume of air by total volume, can be written as volume of void minus volume of water by total volume. Now volume of voids by total volume minus volume of water by total volume. We separate this equation. What we know is volume of voids by total volume is what? It is porosity, right? So we write out N, we represent porosity in terms of N. Next, we don't know what is volume of water by total volume, but we know if we multiply both the denominators and numerator with this volume of voids, we can get an expression. We know volume of water by volume of voids, what it is. We know it's S, right? So we can write it over N minus S, and again volume of voids by total volume is N. So if we take N common, this is coming out to be N into 1 minus S percent. Okay, so this is how it's coming, the year void ratio. Next, looking at the year content is actually volume of year divided by the volume of voids, right? It's actually the volume of air divided by volume of voids. So if someone asks me, if question comes somehow like this, that ace is equals to say 30%, so what will be my air content? So air content, I can write it as 100 minus 30, it will be 40%. Why? Because air content plus Ace is always 1. Since air content is volume of air by volume of voids, and we can say Ace is what? Volume of water by volume of voids, which is equals to, we can write this somewhere like this, volume of air plus volume of water by volume of voids, and this together forms again the volume of voids. So this is coming out to be 1. Right, so this is actually equals to 1. So just remember this, people often get confused between the year void ratio and year content. Year void ratio, year content, both in both cases numerator is the volume of air, but the denominator in year void ratio is the total volume, and in year content it is the volume of voids. Now let us see the weight relationship. There is only one weight relationship, that is the water content. Water content is the ratio between the weight of water and weight of solids. So can water content be equals to 0? If water content has to be 0, that means weight of water has to be 0. Okay, in the three-phase system, the weight of water, this is here, this is water, this is solids. That means the weight of water has to be 0, and it is definitely possible that if weight of water becomes 0, it is possible. So we can say water content can be equals to 0, and remember it can have any value greater than 0. Why? Because weight of water can be greater than weight of solids also, because say we are getting somehow weight of water as um, 10 kgs and weight of solids as say 8.5 kg, so it is coming out to be greater than that. It is also possible. For that, there is no upper limit to water content. It can have any values greater than equals to 0, and water content may be greater than 100% as well. So let us now look at some of the relationships that we have. So what is unit weight? Unit weight is actually, I already discussed, is the ratio between the weight and volume, right? So bulk unit weight means the total. In the soil mass, the total weight of the soil mass divided by total volume of soil mass. So the total weight of soil mass comprises of the weight of solids and water, since here weight is 0, and the total volume comprises of the volume of voids and volume of solids, and volume of voids we know it's volume of air and volume of water. Okay, next dry unit weight. When we are talking about dry unit weight, we mean to say that my weight of water is 0, that means only solid is present. That's why we are writing in ws, which is the weight of solids divided by the total volume. In saturated unit weight, we have the saturated weight divided by volume. Submerged unit weight, this is important. How to find out the submerged unit weight? Remember, from the saturated portion, if we subtract this gamma W, which is the unit weight of water, which I already told is 10 kilonewton per meter cube, I discussed earlier. So if we subtract this portion from the gamma sat, we will get what is called gamma sub, or we can say the submerged unit weight. Unit weight of solids is something weights of solids by the volume of solids. This representation will come a bit later. Okay, let us discuss first few of the relationships between the different terms. First is the void ratio and its relationship with the porosity. For example, in the question, if it is given the n value, that is the porosity value is given, and if you are asked to find out the void ratio, how to calculate it? Okay, so void ratio is somehow we know it's actually equals to volume of voids divided by volume of solids, right? So volume of solids, can we write it as total volume minus volume of voids? Now what I'm doing is I'm bringing this portion down. So what I can write is V by VV minus VV by VV. Okay. So volume of voids, we know n is what? Volume of voids by total volume. So it's like 1 by n, and this is 1. So it's coming out is n by 1 minus n. So E is equals to n by 1 minus n. Similarly, we can find it out this also. So if you're given the value of E, say E is given 0.5, you're asked to find out n, what it will be? Say example, it is an example, okay, say suppose. So we'll find out 0.5 divided by 1.5. So it will be 1/3. Right. So this way we can find it out the various values. I'll come to the questions in my next videos. I'll discuss different questions based on these relationships. Okay. Remember the relationship between specific gravity, void ratio, water content, and unit weight of water. Okay. So GW is not the relationship. It's unit weight of water. Now just cut it down and write A. Sorry. Yes. Remember this equation is required in all problems. Most of the problems will require this equation. GW is equals to AC. Just remember it. GW is equals to AC. Okay. Next, moving on to the total unit weight. Total unit weight, this is remember as a parent equation or parent relationship. Gamma is equals to G plus AC into whole. This is all together is multiplied with gamma water, that is the unit weight of water, by 1 plus E. Now since from this equation we can write like we know GW is equals to AC. So in this place of AC, we can write G plus GW divided by 1 plus C into gamma W. Now if you from here both the portion, if I take G as common, this is coming out 1 plus W into gamma W divided by 1 plus C. So this is how the equation is coming from here. Okay. So consider this as a parent equation. This from here we will come to other equations. For example, if I am considering the soil as dry soil has AC is equals to 0 and wet soil has AC is equals to 100. Right? So in case of dry soil, S becomes equals to 0. So gamma dry will come out to be equals to G into gamma W by 1 plus E, because this term will not be there, SE. Since S is 0, 0 into E will become 0. Right? So here we'll get the gamma D as somehow like this. Now, if we say S is equals to 100, that means this is saturated soil, fully saturated soil. and this is for the dry soil, right? So ACE is equals to 100, or we can write it as 1. So when we are putting the value of ACE as 1, so it's become E because it was ACE. So G plus E by 1 plus C into gamma W. This is when ACE is 100%, or we can say the value is 1. Next, we move on to the dry unit weight, which is gamma D, and gamma D can be represented as gamma, which is the bulk unit weight, or we can say it is the weight by total volume by 1 plus W. This equation is also important while solving problems, and in the upcoming chapters also you will find problems coming from this equation, or utilization of this equation is required. Now let us move on to the portion which I have skipped earlier. So if I'm asked to find out which unit weight is the greatest of all, means come, this is the unit weight of solids, this is the unit weight, saturated unit weight, this is the unit weight itself, the bulk unit weight, this is the dry unit weight, and this is the submerged unit weight. So if I write it down as, this is the unit weight of, remember this is the unit weight of solids, this is saturated unit weight, this is the bulk unit weight, this is dry unit weight, and this is submerged unit weight. So this relationship is required and it's very important in exams also. But how it is coming, I'll just show you. Since gamma, the bulk unit weight, I already discussed that gamma can be written as G plus AC by 1 plus C into gamma W, right? So from here, can we write when is, this equation will have maximum value when AC is equals to 1, right? So AC is equals to 1, we are getting gamma saturation, and it will have minimum value when AC is equals to 0, right? So when AC is equals to 0, this is becoming gamma dry. So gamma sat will be the biggest one, gamma dry will be smallest, because in gamma dry we get gamma ds G into gamma W by 1 plus C. This plus portion is removed, and in saturation portion this is the highest portion that we are having. So obviously from here we can say gamma sat, obviously it will be greater than gamma dry, right? And somehow we can say this bulk density will be somehow in between these two, because for gamma we can have any value, say 0.5 or somehow zero point 0.7 or anything, right? So this is somehow like this. So this three relation we already established. Now what is the gamma sub? We know that gamma sub, or submerged unit weight, is equals to saturated unit weight minus gamma of water, right? And saturated wise we can write it out from this equation. Saturated is when ACE becomes equals to 1, so the equation comes out somehow like this, G plus C by 1 plus C into gamma W. So I write it down here to gamma W minus 1, minus gamma W. So if I take gamma W as common, what it comes out to be equals to G plus E minus 1 minus E by 1 plus E. So plus C minus E gets cancelled. It comes out to be gamma W G minus 1 by 1 plus C. So out of all the equations, this is the smallest one. So this will come out in the last. And always remember, since this portion, this is actually the unit weight, will be the highest of all. So we finally establish the relationship between all. So the maximum one will be the solids, unit weight of solid will be the highest, then will be the saturated unit weight, then will be the bulk unit weight, then the dry unit weight, then will be the submerged unit weight. Hope everyone has got this chapter clear to you. If there are any questions or portion which you are not being able to understand, do comment in the below section, or you can mail me also. I'll attach my mail ID below. In my future videos, I'll be discussing the questions from this chapter, and finally I'll be coming on to the different properties of soil. Mostly the index properties I'll be discussing in my next to next videos. Okay. till then, do study well, try out the questions, um, try to find out the relationship among by yourself among the various terms, among the various unit weight like void ratio, how it is coming as I showed you. Try it in your paper at home and let me know if you have got any problem. So guys, do like, comment and subscribe my videos. I'll come up with more videos in the recent times. Thank you.